Hi guys, welcome back to Symbolic Logic part 21. So far we have seen about rules of inference by replacing the truth table. As we know, truth table is troublesome and we need concentration to prove using the truth table. So we have 9 rules of inference which we will be using to prove the validity of an argument which will be provided in the problem. So let's see, recap what are the 9 rules of inference. Number one, we have modus ponens, two modus tollens, three hypothetical syllogism, four distinctive syllogism, five conjunction, six constructive dilemma, seven simplification, eight absorption, and nine as addition. So using these 9 formulas, we are gonna prove whether the given argument is valid or invalid. So the question is how you will be getting us prove the validity of each of the following arguments. So when I say about validity, we have two things to consider. One is valid argument, another one is invalid argument. How you will find whether the given argument is valid or invalid? How you will be find? I know you will be solving using the rules of inference. So if this rules of inference gives true or false, how you will be finding it? As you know, I said earlier, the difference between valid and invalid argument, you can refer my previous back videos. So I will recap it again. So, valid arguments in the sense, let's complete the invalid argument part. So, you will be understanding the valid easily. So, invalid means in the argument, we will be having premises and conclusion. So, if an argument is invalid, then all its premises will be true, but the conclusion will be false. Then it is a invalid argument. When it comes to valid argument, all the premises will be true and the conclusion will also be true. Then we consider that type of argument as a valid argument. So let's see problem number 1. We have M distinction N, negation as first premise, and negation M conjunction negation O as the second premise. And conclusion we have N. What we have to prove is LHS is equal to RHS. So using the first premise and the second premise, we're gonna prove first premise and second premise is equal to the conclusion. So what we're gonna find? First premise and second premise, using the rules, we're gonna bring N in LHS, which is equal to RHS N. So let's take second premise first. Negation M, conjunction, negation ho. How we can simplify it? If you take the seventh rule in rules of inference toolbox, we have simplification. Simplification. So simplification in the sense P dot Q. I mean conjunction. P dot Q gives P. So negation M dot negation O gives M. So we got negation M from second premise. Let's say take the first premise again. So M distinction N, and also take the value which we got from solving the second premise, which is negation M. So let's take this both the premises at the same time. First premise and the value of second premise. Apply fourth rule, which is distinctive syllogism in it. What is distinctive syllogism? P or Q. Negation P, which gives Q. P disjunction Q, negation P, we get Q, which is similar to the value we have. M disjunction N, negation M. What we will get? N. So applying simplification in second premise and distinctive syllogism in first premise and the value of second premise, we are getting the conclusion N, which is equal to the right hand side. So that's proved this argument is a valid argument. I hope it understands. Practice more these types of problems so you will get an understanding on how to prove step by step this validity. So let's see problem number 2. We have A implication B as first premise, B implication C as second premise. What we have to prove is the conclusion A implication C, which is in the right hand side. So in the left hand side, how we gonna prove is, let's take the first premise A implication B and second premise B implication C, and match it with the third rule of inference, which is hypothetical syllogism. P implication Q, Q implication R gives P implication R. So A implication B, B implication C gives A implication C. That's what proved. Therefore, this argument is a valid argument. This is how we prove it. So The third type of problem is how you will be getting the question is P implication Q, conjunction, R implication yes, as first premise. And second premise you will be having P disjunction R, conjunction, Q disjunction R. And the conclusion you will be having Q disjunction S. So you have to prove Q disjunction S. LHS is equal to RHS. So take the first premise. P disjunction Q, conjunction R disjunction S. And take the second premise. P disjunction R, conjunction Q disjunction R. Now think how we can simplify this both the premises to get Q disjunction S. So we are applying some simplification in second premise. So we are taking P distinction R as P and Q distinction R as Q. So P conjunction Q we will be getting P. So we are getting P conjunction R as the value by applying simplification in second premise. So as you already have first premise and you have second premise value. Now you apply sixth rule, constructive dilemma. Constructive dilemma we have what we have? P implication Q, conjunction R implication yes, PVR, P disjunction R, therefore we get Q disjunction yes. So applying 6 in it, we are getting the conclusion. So LHS is equal to RHS, that's proved. So let's take the next problem we have. Negation H, disjunction I, disjunction J. First premise and second premise negation H distinction I, and in conclusion we have to prove J distinction negation H. So in the first premise, take the first bracket as P and J as Q, and take the second premise as P, that is we have negation now, so negation P. So write it as negation P distinction Q, first premise value, second premise value as negation P. So apply the fourth rule, distinction dissyllogism in it. P distinction Q, negation P, we will be getting Q. So we got Q. What's the value of Q in question? The value of Q is J. So we got J. So apply simplification to J. Apply addition rule to J. So we will be adding distinction negation H. So we got J distinction negation H. This sum seems to be complicated, but it is really easy if you understand these problems. Make sure you have time to practice the problems again and again with the different values. So you will not be confused in the last minute. So be patient and practice regularly to understand these complicated problems. And it will be easy and time consuming in the exams if you prepare from the very first starting. So in the next session, we will be studying about many rules apart from this inference rules.